morning, everybody. How we doing? How excited are you all to actually be back in person? I mean, I feel pretty darn good about this because I spent the last 2 years talking to a screen and hoping that there were people on the other side. And so for me, it is, just joyful to once again have people in front of me, and I can see you and I can see your reactions. And for me, that is huge. So thank you all for venturing out and joining us. We really do appreciate that. So in case you haven't figured out who I am, my name is Nate Schutta. I do work for VMware. Best way to describe me is architect as a service. You know, before the pandemic, I used to go places and talk to people about architecture and cloud and things like that. And then the pandemic happened and I just sat in my den, which is when I realized that I talk with my hands and I don't have an indoor voice. So my wife and I share an office now, and before it was just me in there, and it was no big deal if I used my professional speaker voice. But then my wife joined me in that office, and one day she was on a meeting while I was also doing a meeting, and someone on her call said, "Christine, I think you left your TV on." And she said, no, that's just my husband, which now means every week she and I have to go through our calendars and be like, okay, so what do you got going on Wednesday? You know, so it's been a lot of fun. So anyway, I'm here to talk to you today a little bit about CICD and all that fun stuff. Now, I've been doing this software thing for a while, and it used to be simple for some value of simple. You know, we had a monolith, maybe two. We released versions semi-annually. We all worked on the same floor, or at least within walking distance of one another, but that's definitely not the world we inhabit today. There's a pretty good chance that you have dozens, hundreds, maybe thousands of services. You might not even have an accurate count because new versions are coming out and services are coming and going, and we don't all live in the same space anymore. I think that's been one of the most interesting outcomes of the pandemic for me. It was this forcing function on getting companies to realize work from home is here to stay. And actually, I would say from a recruiting standpoint, this is a huge win because the odds of us having the best talent within a reasonable drive of our corporate headquarters is essentially slim to none. So being able to recruit from anywhere is a huge win as far as I'm concerned. Now, developing applications has never been what you would call an easy thing. But now we have these massively distributed applications with teams scattered everywhere. We can't keep doing it the way we've always done it. The single most dangerous phrase I hear when I work with clients is, "That's how we've always done it." We have to banish that from our vocabulary. That does not mean it's the best way to do it, the right way to do it, or the way we should keep doing it. So how did we get here? Well, if you go back not that long, frankly, in our industry, software development was a very, very siloed occupation. All of you have heard of waterfall at some point. Many of you, I'm sure, have felt the joys of waterfall software development. You know, one phase flows into the next, and you know, it's this very rigid kind of one-way traffic approach. And in theory, it makes a lot of sense. You know, we get all the requirements, and then we do the design, and then we do the building, and then we do the testing, and then we do the maintenance phase, which of course I was told is the longest phase, which I always said, well, isn't this more like a product rather than a project? It doesn't really have an end date, does it? And to be fair, this worked for some definition of worked. And our teams, of course, were very siloed in this era of software. You know, we used to have these little boxes that we all had to fit in, and you know, we had the business analysts doing their thing and the developers doing their thing, a little saucy UI on there, and testers were over here, and nobody talks to the operators. And of course, we never really worked all that well together. Sometimes it was very acrimonious. There was a lot of animosity between groups, and some instances it was borderline trench warfare, let's be honest. We had these very prescribed handoffs. It was all one-way traffic, and it was scheduled and heavily limited. We could only do it a few times a year. Oh, we missed this quarterly release. You can't have that feature now for another 3 or 6 or 9 months. Another way of thinking about this, of course, was, well, just throw it over the wall. I mean, I literally heard that phrase, throw it over the wall to QA. Now, in fairness, the woman sitting in the cube next to me was, in fact, one of our QA engineers. So it kind of sort of made sense. You know, throw it over the wall, and she'll take care of it. We said that a lot. Now, that didn't always work particularly well. This tweet just always makes me laugh. You know, oh, wait, we're trying to break the glass. That didn't work. All right, throw a sledgehammer on it. There we go. Now we solved the problem. Or this one. I saw this recently, and it just cracked me up. Testers don't like to break things. They like to dispel the illusion that the thing worked at all. Isn't that the truth? Now, of course, this style of software meant there was a lot of finger pointing, there was a lot of excuse making, there was a lot of, hey, it works as designed. I'm unable to reproduce that. Or my favorite, works as coded. It did what I wanted it to do. Sorry, that wasn't what you wanted it to do. And of course, the operators would get mad at us because we pushed out a release and broke prod again. And let's be honest, not exactly an ideal way to work. Our cycle times were measured in like phases of the moon. It wasn't exactly rapid. Although I have to admit, if this was my morning commute, maybe I would take my time too. Now, as much as we wish things were just the way they were, that's just not how the world works. Business cycles have sped up ridiculously. We have to adapt to that. We have to adopt this always be changing mindset. We can't afford to turn things around in months or years. When I first started in software, I swear every estimate was like 18 months. That was like the stock estimate. That'll be 18 months. And that was okay, I guess, because our customers are like, well, I guess we don't really have a choice, do we? That doesn't work anymore. We need to be able to turn things around in days or weeks, certainly not months. Now, the first spring one I attended as an employee, a gentleman from Scotiabank got up on stage and talked about their journey from the traditional, quarterly releases to doing thousands of deploys. Now, to be very clear, this does not happen overnight. This isn't the kind of thing that, we talk about it on Tuesday and by Thursday we've done 497 deploys. There's a lot of engineering discipline that goes into that. There's a lot of culture change that goes into it. That's the hardest part, by the way, is the culture change. The technology stuff is fairly trivial. Now, what was really interesting to me is some of my former colleagues were at this event. We were chatting in the hallway, and one of them said to me, Nate, we're never going to be able to do that. I said, why not? He said, well, because you worked with us for years. We're really conservative. There's no way we can adopt those practices. I said, did you not catch that guy was from Scotiabank? It's a bank. There are few institutions that are more conservative than banks. So if they can make this change, what does that mean for us? So whether it's convenient or not, whether we like it or not, speed matters today. Disruption is affecting every single business. None of our industries are immune. If you were a grocery store chain a few years back, you were probably thinking, technology, who cares about that? I don't have to worry about that. And then Amazon bought Whole Foods. And all of a sudden, now you're competing against Amazon. Now, I spent a long time in the insurance industry, and there's rumors in there about, hey, is Google really a competitor to insurance companies? Because what does Google do? They manage a lot of information. That's kind of what an insurance company is doing. Well, insurance company is kind of an interesting sort of investment vehicle, but anyway. Whether it's convenient or not, we're all technology companies today. This is, I think, the biggest shift I've seen in my career. When I first started right out of university, my first day on the job or somewhere the first week, we had this presentation from the CIO to all the new hires, and he made it very clear that we are not a technology company. We, as an IT department, are here to support the business. We are a cost center. He was all but saying we are not strategic. Now, fast forward, 18, 20 years, I'm with a completely different client, completely different job. Their CIO gets up in front of a room full of developers and says, folks, we are a technology company that happens to be in retail. It's taken the C-suite a long time to get their heads wrapped around that. That's kind of inconvenient for some. It's actually very nice for us, to be honest with you. So what do we do about that? Now, if you ask a software engineer, how should we improve this process? What is a software engineer likely to say? Well, let's make it look more like software engineering because we know how to do that. So let's make it more of that. In other words, please give me more cowbell. Give me more of that. So our testing approach isn't working the way we want. Well, that's not a big deal. Let's make testing look more like software engineering. And so now we're going to say, hey, developer person, you are responsible for writing some automated unit tests. And we're going to free our testing professionals to do the really nefarious stuff. Try things that are not in the norm. This is probably one of my all-time favorite tweets. QA engineer walks into a bar, orders a beer, orders 0 beers, orders a lot of beers, orders a lizard, orders -1 beers, orders a mash on keyboard. First real customer walks in and says, excuse me, where's the bathroom? And the bar bursts into flames. It's pretty much how a lot of our applications work. Or again, testers don't like break things. They like to dispel the illusion that the thing ever worked in the first place. So we made that shift. And then comes the question, well, what about that production thing? To which our operators just laughed at us. And of course, we said, well, hey, that's not my problem anyway, because of course, it works on my box. Problem solved. All right, so what do we do about that? Well, we'll just throw it over the wall. We'll let the prod op folks deal with it, not my problem. Think for a minute if parents did this. Well, the kid's 5, they're the world's problem now. Besides, worked in my house. Must be fine. Now, our operators faced a different set of incentives. They want to keep production up and running. They are almost always judged on availability. And then us developers come along and we say, oh, we're just going to put some stuff into production. They go, whoa, no, because you guys put code in production and then production comes down. I don't like that. If we never released software, we'd have 100% uptime. Big win. Obviously, they could never get away with that. So what would they do? Well, they just make it really hard for us to release code. So what do we do about that? Well, they'll get me my cowbell. Let's make ops look more like software engineering. And then we, willingly or not, signed up to be the first level of production support. Now that has an interesting incentive to developers. In the past, we could be kind of cavalier about a lot of these things. Because, well, that's going to be an operator that gets paged, not me. Oh, wait, you mean I'm the one who's going to get woken up in the middle of the night? Oh, maybe I will spend a little more time and attention making sure that feature is as robust and reliable as possible. Now, obviously, I've oversimplified this quite a bit, but this did allow us to start releasing more frequently to production. This is a huge win for us. Software is built on these nested feedback loops, at least when we do it right. I mean, this is what we're trying to get with Agile. And to be very blunt, everything we do is Agile. You know, assuming you commuted in here this morning, you drove your car in or you walked in from a hotel, you didn't just point yourself in the general direction of this venue, close your eyes and just start walking and hope everything was going to work out. You know, over the course of the last 3 days, outside my hotel, they've been like ripping up the sidewalk, which meant I had to adapt my route every day. That's a nested feedback loop. What I appreciate about being able to get things into production more frequently is I can show my customers progress. Now, I remember being on this one project and having to constantly tell my customers, trust us, this is really great. We're like 83% done. You are going to love this once you get a chance to actually use it. In another, I don't know, I want to say 2 months, but it could be as many as 6, maybe 9, I'm not sure. But we're like 83% done. Now, that's not the only feedback loop we get in this equation, though. When we work more frequently with our operators, we help reduce some of that friction in getting code to production. And then, of course, our operators reflect back to us, you know, the code could be more reliable and more fault tolerant. That would be good for all of us. We'd all sleep better. Turns out sleep's important. The other part of this that I always thought was fascinating is small batch is not just good for bourbon. It's really good for software. There's much less risk here. I've been involved in plenty of quarterly releases. I don't think I've ever been involved in a quarterly release that just worked. Why? Because we're taking hundreds, if not thousands of changes, and we're slamming them together and hoping for the best. That almost never works. Because there's inevitably this interaction between 3 or 4 or 10 or 15 of these different changes that has a negative outcome for us. So we'd have this quarterly release, it would break, and you'd sit there and go, what caused the break? I have no idea. There were 1,800 changes. If we only make a few changes and push it to production and something breaks, it's a heck of a lot easier to reason about that. This also frees us up to run experiments. Hey, let's try this and see what happens. Let's do some A/B testing and see, does this change give us more signups, more conversions, more sales, whatever metric we care about? It also allows us to be much, much more responsive to our business partners, and this is critical. The world is speeding up for them too. They can't wait for us to, yeah, we'll deploy that for you in a year and a half. Now, of course, this helps us too because we can get things done more quickly. We have better quality software. We have better software, and we deliver more business value. This is why we're here. Until code gets to production, it really is kind of a waste. At the end of the day, we get happier customers. That is a very good thing. One of the other big shifts I've seen in my career is software has become a much much more collaborative game than it used to be. Now, I remember being a summer intern, and I was working on writing some documentation, and I would often run into bugs, and I'd have to go talk to one of the developers, and this fellow, I don't think he ever made eye contact with me the entire summer, and it was an interesting experience, to say the least. We don't live in that kind of lone wolf world anymore. This also allows us to align accountability better. And this is where an error budget can be incredibly useful to us. So the idea of an error budget is we establish a target for something we care about, like availability. And so we decide that our target for availability is 2 nines. That means my error budget is 1%. As a development team, I am free to spend that 1% however I want. I just can't exceed it. And if I do get close, well, all right, I might have to slow down a little bit. Maybe we've got to wait to do a release till Tuesday instead of doing it today. The goal is not 0 outages. There is no such thing as 0 outages. We're just trying to stay within the error budget. So as a development team, we can experiment all we want. We can try all sorts of cool stuff. But once we use up our budget, we got to slow our roll a little bit. The huge benefit here is we now have aligned incentives. We're on the same page. Instead of this being a fight between the app team and the operations team, no, we're all on the same page trying to get to the same outcome. We start to understand this as a cost-benefit trade-off. It's all trade-offs in software. Now, I would also argue it is in our best interest to align how we're measured, too. You know, traditionally, we have been measured based on velocity in some way, shape, or form, and our operators get measured on availability or something similar. Well, at the end of the day, we are trying to put code into production. We are trying to deliver business value. That's what we should be judged on. You know, I remember reading Grapes of Wrath at some point along the way, and what really struck me was the central message I took out of Grapes of Wrath, at least, was that shift culturally from I to we. That's what we need to start doing in software as far as I'm concerned. So what can we do to get more features to production more frequently? How do we do that? Well, that's a pretty heavy dose of automation. Now, you go back far enough, our builds were these crazy Rube Goldberg machines. All sorts of manual tasks. And I remember when we first started doing, quote unquote web development, it's like, okay, well, right click on your IDE and generate that artifact, and then you're gonna copy that to this magic drive location where we've got some hard-coded credentials, and don't tell anybody, but if you know the right place to look, you can find the non-expiring usernames and passwords for all the database stuff, so if you really wanted to go mess things up, it's right there in clear text. But it's security through obscurity. You just don't pretend you don't know where it is. And of course that worked, for some definition of worked. And it was okay because, well, we just didn't do it very often. So it wasn't a big deal. I didn't realize how hard-coded our deployment process was until I left a team and had to transition all of the stuff I did to one of my teammates. And that's when our sort of operator person was like, well, yeah, actually, Nate, it's your ID that's hard-coded in there. I'm like, wow, so what would happen if, I don't know, I got hit by a bus one morning? And his response to that was, don't be so macabre. Yeah, but it could happen. Now, I'm a huge fan of artisanal coffee. I seek this out in almost any city I'm in. That is one of my team's superpowers. We will find the best coffee in a given city. I have thoughts on that. Let me know if you have questions. And I do like taking my time to find that. But you know what? I don't want that in my builds. Really don't want that in my builds. Human beings are incapable of doing the same thing twice. It's just not in our capabilities. If you do not believe me, take up golf as a hobby and come back to me on that one. This is something my teenager does not understand. He somehow thinks because he once hit a perfect golf shot that every golf shot should be perfect. It's like, buddy, that's not how the game works. Human beings have bad days. Human beings get bored. We have a fight with our partner. We have a bad experience, maybe our stomach's upset, we skip a step, we fat finger a command. This happens more frequently than we care to admit. Some of you, I'm sure, got this wonderful email. This template for integration testing only. I saw that and kind of laughed about it. I'm like, oh, that's pretty funny. I'm sure there's some people who got that and were like, what's an integration test? And so I really appreciate that Emily tweeted out, hey man, we got your back. It's all good. Just take a deep breath. Could have been any one of us. Because it could have been any one of us. We've all done something like that. You could have a really fascinating presentation that's nothing more than we all get up on stage and talk about, hey, this was my dumbest mistake. One time I almost deleted my entire hard drive trying to write a little script that was going to clean up my build. Oops. Should always run that dry, I learned that day. Computers, on the other hand, don't ever get bored. They don't ever skip a step. They do what we tell them to do. And sometimes that's really cool, and sometimes that's maddening. Why didn't you do what I thought you were going to do? I learned a long time ago that in computer science, there's only 3 numbers. There's something we do 0 times, there's something we do once and only once, and then there's n. If you do something more than once, you are probably going to do it a billion times. So if you do it more than once, you should find a way to automate it. Our goal here is to offload that toil to the computer. Make the computer do what the computer is good for. Venkat's here this week. It's great to see Venkat again. I love this tweet. Do manually only the things that give you intellectual pleasure. Automate everything else. What we're striving for here, friends, is consistency. I need this to be done the same way every single time. I need CI and CD pipelines to do that. We've written about that. The GitHub folks have written about that. All sorts of stuff out there on the interwebs for you to peruse. Now, I want to stress this does not imply that you will make a commit and 30 seconds later that commit is running in production. That is possible. Some teams do that, but that's kind of extreme. It's probably not where you're going to start for sure. We've been doing CI for a long time. This is not new by any stretch of the imagination. The idea here is we're going to merge early and merge often in an effort to avoid merge hell. We have all been there at some point. You've been working on something for a week or two, and then you go to check it in and you realize, oh no, someone else has also modified this file. What do I do? But the idea here is that we've got some automated things sitting around every time we check in code. A bunch of stuff gets triggered. We run some code quality scans, we run some tests, et cetera, et cetera. And what we're trying to do is make sure that any commit we make didn't break something in the application. It's not going to catch everything, but it catches, most things, hopefully. From there, we can extend to CD, continuous delivery. So let's take that build to the next step. How do we get those releases out to our customer? So how do we carry automation through into the deployment and release management stage? And one of the things that has really become a lot clearer to me is the fact that there is a distinction between a deploy and a release. We can deploy code and not release it. So just because it's deployed doesn't mean the customers can necessarily get to it. One of the complaints that we get, and I certainly remember this from my previous life, well, we're not ready for that change yet, so you can't deploy that to production yet. But the code's ready, it's all tested, it's good to go. Yeah, but they're not ready to take it, they're not ready to change their training or update their manual or whatever process they have in place. Okay, well, with some of the new feature flag concepts that we've been using for, several years now, you can call it new, we can put that code into production and we'll just wall it off, so, it's not actually available to you yet. That's a huge win for us. The goal is to allow us to decide when we release that code. Not just us. Obviously, it's our team, it's our customer, et cetera. We want to be in a releasable state as often as possible. And we do that by working, again, in smaller batches. I've never understood why we wanted to do these massive releases with lots and lots of changes and why we thought that was a good idea. Again, you think about having hundreds, thousands of changes, all these integrations, which one caused the break? I have no idea. Could have been any one of them. Probably wasn't just one, as I said earlier. If I only push a couple changes, guess what? There's a pretty good chance that's the one that caused the problem. The other important piece of this equation is how do we get good at something? It's through reps. You got to put in the time. This is another thing I've had to instruct my teenager on more than once. How could you expect to get good at something if you only do it a few times a year? My favorite example of this is tying your shoes. Every single one of us knows how to tie our shoes. There was a point in our lives where we did not, in fact, know how to do that. Now, if I actually asked any one of you, how do you tie your shoes? you would sort of almost, you'd beach ball for a little bit. You're like, I don't really know. And you'd probably do like some kind of motion with your hands. But if I actually asked you to slow down and describe it, your hands would be all fumbly and you wouldn't know what to do. That's because you have tied shoelaces countless times. If you only push to production 3 or 4 or 5 times a year, how can you possibly be good at it? What incentive do you have to buff off the rough edges? This is one of those rare things where, oh, doc, it hurts. Good, do it more. That'll make it better. Deploy early, deploy often. You will get better at it. You will be forced to address those problem domains inside your process. The other part of this that is so powerful is it gives us trust in the process. We know if something goes wrong, okay, no problem. We can put a fix out and we can get that into production reliably and repeatably. This gives us recoverability. I've been part of a lot of very heavyweight SDLC kind of processes, and if I put the best spin on it I could, the idea was, well, we had this problem and we want to make sure this problem never happens again, so we're going to add this step to the process to make sure that we don't ever have this problem again. That's the best spin I can put on it. Now, the problem, of course, is we almost never audited that process to say, hey, does that step actually prevent the bad thing from happening? And of course, no one ever wanted to have the conversation about, well, what if the bad thing still happens despite the fact that we have a step in the process that's supposed to prevent it? So there will be outages. Mistakes will be made, but not by me. There's actually a very good book along those lines. Mistakes were made, but not by me. It's all the ways we try to, oh no, it wasn't my fault. So yes, outages will happen. We will write bugs. What we want to focus on is how quickly can we recover from that? How quickly can we get that fix into production? And the only way we get there is through heavy, heavy automation. And not only does that give us some confidence, just think for a minute what it would be like to use any kind of editor if you didn't have undo. Do you guys remember when undo was only like 1 level deep? And now, I don't know, it's like infinity, right? You just keep hitting, Command Z until everything goes back to normal. Imagine trying to write software without version control. Some of us have done that at some point in our lives. Some of us have had the joyful experience of, I got that to work, cool. I should probably commit that, but nah, this source code control doesn't let me do that very easily. So I'm just going to keep doing some more changes. Uh-oh, nothing works anymore. How do I get back to where I was this morning? Oops. That's huge for us. We need robust pipelines, and there are a ton of great tools out there. Use the one that makes you happy. Most of them are cloud-based now. It's really fascinating to see how much of this is just getting baked right in. So you look at GitHub Actions, some of that's right there now in our source code management tools, which is awesome. We also need to think a bit about our deployment strategy. What is our approach going to be on that front? Now, in the beginning, we only had one, and that was nuke and pave. We are going to overlay the current version with the new version, and fingers crossed, hope everything works. What could possibly go wrong? Well, lots of stuff. It almost always meant that release weekends were a lot of anxiety, a lot of sleepless nights, a lot of everybody on a conference call till odd hours of the morning. I'm sure you've seen those wonderful messages, this application will be down for maintenance. What amazes me is those messages still show up today. So this is my friend, my coworker, my colleague, the one and only Layla. She tweeted this out last summer, and I just laughed. I'm like, you're kidding me that there's a site today, this would have been 2021, that's down for maintenance? What's that mean? Do you not understand how the cloud works? And so my response to Layla was hey, certain deployment strategies are not evenly distributed in the wild yet. Now, I laugh about that as a technologist, but there's serious business repercussions for that organization. Thanks to the interwebs, the friction here is zero. Layla can just go anywhere else. She can point her browser at one of your competitors who is not down for maintenance, and she'll just make the purchase there instead. You lost the revenue, and you may have lost a customer. Whether it is convenient for us or not, our customers' expectations have changed radically. I remember the first application I worked on out of school, the standard uptime sort of guarantee from our IT people was the 6x6, 5 days a week, right? So 6 a.m. to 6 p.m., Monday through Friday. That was all they would guarantee us, which was kind of a bummer because I had customers in the UK, which meant for them the application wasn't guaranteed to be available until noon. Well, that's kind of a bummer. But what are you going to do? Sorry. That doesn't fly today. We cannot get away with that today because if your site is down, don't worry, your customer's not. Now that evolved into the recreate pattern, which is, okay, let's spin down the current version and then we'll spin up the new version. That has the advantage of being simple. It has a disadvantage of, we could be down for a few hours. Turns out that's not exactly ideal. That sort of evolved into the idea of a rolling update. So we'll do a subset of our instances, and it's usually defined as a window size. We'll update those, and then we'll keep kind of rolling through till we get everybody. So yay, no downtime. Boo, not everybody's got the same version at the same time, and rollback is kind of a challenge. So I hope you are backwards compatible. And you have heard the phrase sticky affinity, right? You got your session management thing figured out. You don't want somebody coming into one version and the next request goes to the old version. Now that morphed into blue-green deploys. I'm sure you've all heard this one at one stage or another. This was sort of popularized by the continuous delivery book. The idea here is we have two identical deployment environments, one of which is currently serving production traffic. We'll call that blue. It does not matter. And we are actively testing the new version on green. If everybody goes, yep, this feels good, customer's happy, we're happy, awesome, change the routing table. Now production traffic is hitting green, and we're going to let blue be idle. Now, if it turns out we missed something, well, that's okay. We'll just switch the routing table back, and blue is ready to go. Life is good. Now, if everything goes according to plan, awesome. Guess what? Blue is now staging. Blue is now that test environment, and then we'll go ahead and alternate back and forth from now until we decide to shut this thing down. The real big advantage of this, beyond the fact that it's very easy for us to roll back, we were testing disaster recovery on every single deploy. That is huge. A lot of organizations sort of paid lip service to disaster recovery. Oh yeah, no, we got backups. Have you ever tried to recover from those backups? No? Okay, then you don't really know what you got. That happens on a shockingly frequent basis where people have not tested the backup and then the bad thing happens and they try to restore only to discover that, well, it turns out the backup actually hasn't run for about 3 weeks and so we just lost a bunch of data. Oops. Now, data is the hard part of this equation, and I would argue this is part of why we keep seeing new databases coming into existence that try to help make this easier. But it does give us zero downtime, and it does give us a simplified rollback strategy. Also radically reduces risk. Now, this can be a bit more expensive because I have duplicated 2 versions of prod, but I do have a little more control. Got to think about backwards compatibility. Got to think about how we're going to sort of drain down those transactions. Can't just kick everybody off. Sorry, we're in the middle of an update. Sucks to be you. Try again later. Now, there is a variant of this called red-black, which is pretty darn similar, just with different colors. So branding. Now, I have heard some people argue that, well, with blue-green, you can have both versions serving traffic, whereas red-black, only one version can serve traffic. So does that mean red-black is a specialization of blue-green? I don't know. We could debate that later if you were so inclined. Or as my old boss loves to say, who wants to argue about the definition of made-up words with me? This is a very popular thing to do at conferences, otherwise known as the hallway track. I would argue same basic concept, different names, a little different branding. We can also do a Canary release. If everything looks good in staging, we can go to Canary. So now we're going to test with real traffic. This is the canary in the coal mine. We want to find out if we have an issue before we unleash everybody on this thing. So that is going to be some percentage of production, 5%, 10%, whatever we're comfortable with. That can be a sliding scale. That can move up over time. Every few hours, we add another couple percent, whatever makes sense for you. But canaries are serving real production traffic. And we are monitoring that to make sure there aren't any issues. If there are problems, okay, automate that rollback to what we were doing before. So how long should we live in the canary stage? As long as it takes. Might be a couple hours, might be a couple days. I don't know. I learned a long time ago that in our line of work, there's 3 answers that work for every question. There's 42. That's to check out who's well-read. There's another layer of indirection, which happens to be my favorite pattern as an architect. But there's the answer that I have to give to almost every question, which is, it depends. This is such a frequent thing to say. My friend Mark actually had a t-shirt made that says, it depends on it. I told my grad students last fall in the architecture class, I said, hey, just so you know, the answer to everything this semester is it depends. And that cohort jumped on that phrase immediately. That's like all I heard for the rest of the semester. I may have overcompensated a bit there on that one. Now, this does allow us to test real production scenarios without impacting everybody. Gives us zero downtime, simpler rollback, but make sure you've got observability in place and you've got monitoring in place. Now, this also can potentially be time-consuming, but for certain risky changes, this is actually very useful to us. Again, we got to think about backwards compatibility. We got to think about session management. Now, there's another concept in here called A/B testing. This is extremely common. Experiments are awesome for us. So the idea here is we have 2 or more versions of this service running at any one time, and it allows us to do experiments. It allows us to do some testing. Let's see what happens if we make this tweak. So some percentage of users get the experiment, some don't, and we compare and contrast. Now, there's this apocryphal story about Google testing like 42 shades of blue or something on a link, if I remember right, from back in the day. And for a long time, the only companies that could do A/B testing were big tech companies, and the rest of us were like, oh man, that'd be really cool. But think about how many times you've had an argument with your peers about, oh, this is totally going to increase conversions or increase sales, again, whatever metric you care about, and you're just sort of like guessing. You know, you may have a lot of confidence because, hey, I know my code works, but let's get data. Although, again, make sure you've got your observability story straight, and you know, it is possible, of course, to break your application if you're not careful. Now, obviously, these are not all mutually exclusive. You know, you could do rolling blue-greens, canary blue-greens, whatever makes sense to you. Now, you all know the answer to this question. It depends. Yeah, there is no one answer here, friends. You got to look at your situation. You got to look at your application. What do you need? What makes sense for you? Different apps have different needs. The goal here ultimately, though, friends, is automate everything you can, then automate some more, and then when you're done with that, keep automating. Now, if you're having a hard time convincing a decision maker that this is worthwhile, you should send them a link and some stories about the night capital glitch. This should get their attention. This was essentially some zombie software that bankrupted a company in a few hours. So what had happened in this situation, and it's amazing to me that there's actually like an SEC filing that has technical language in it that we software engineers could get our heads wrapped around. They repurposed an old flag. Big no-no. Then they did a rolling deployment, and they missed one of the servers. 7 servers got the new code, 1 didn't. This is not, in fact, fine. They wiped out nearly $500 million in market value overnight. And in less than a week, they were acquired. I'm guaranteeing that did not end well for the folks that were involved in that process. That was not a comfortable after-action discussion, retrospective, whatever you want to call it. So what's the lesson here for us, other than be very cautious when we try these things in the wild? We need reliable, repeatable releases. We do not get reliable, repeatable releases if we rely on human beings doing everything right. That is not possible. We are humans, not robots. Automation is your friend. This is how we get a good night's sleep. Now, I would argue, friends, this is just yet another example of shift left, shift left, shift left. Let's try to fix issues when they are easier and cheaper to fix. You know, it turns out if you bake a cake and you decide, oh, you know what, I really like chocolate more, I want to refactor this into a chocolate cake. Sorry, it's too late. Like, you can't do that. I mean, I guess you could put a lot of chocolate frosting on it or something, but it's not going to be the same. So we do have to put some thought into this. Now, if you're not sure how to do this, turns out my friends on the Spring team have some thoughts here. I do want to emphasize this is not us trying to own your build, right? It's just an opinionated approach, gives you a place to start. The whole goal is take this, modify to your heart's content. The more we do this, the more I hear X as code. We're trying to get more and more of this to look like code. Again, it's, give me more cowbell. So infrastructure as code, configuration as code. And so what this is ultimately doing is building bridges and knocking down walls. I think that's huge. We're starting to see infrastructure move to more of a self-service model. This is great. I remember back in the day, you asked for a server and like 9 months later, a server would be stood up. We requested a development database once, a development database. This was something we were just going to put some architectural diagrammy stuff in. It took a year. I was just like, a year? I mean, did they write a database as part of this project? I mean, what takes a year? So this is a huge win for us. Now, the other part of this that I get really kind of jazzed about is the fact that in the past, we had to make a whole bunch of decisions very early in the process. Often when we knew almost nothing. Extremely common question to get at the beginning of a project. So how much capacity are you going to need for that new project? I don't know. So what would we do? Well, let's take what we think is our worst case, and then let's double that. Let's add a little more. You know what? Double it again, just in case, because we might need it. There were such lengthy lead times here. There were so many tickets. And by the way, I am convinced that all enterprise ticketing systems are games that we cannot win. If we somehow manage to get a ticket to the right place, that actually sends like an alert to the admin, and the admin comes in and closes off that loophole that we found. So it's meetings and tickets and email and follow-up. It's enough to make you want to flip a table. By the way, as a total aside, my wife saw this slide one day and she looked at me and she said, "What is that?" I said, "It's table flip." She says, "What do you mean?" I said, "See, arms in the air, table in the air, it's table flip." I actually have this as a keyboard expansion on my phone. I just type in TAFL and boop, there goes table flip. She just looked at me, shook her head, walked out of the room and said, "You have a weird job." I said, "You're not wrong." So it was in our best interest to heavily over-allocate resources. Better to have it and not need it than need it and not be able to get it, because it will take so long for us to get more capacity the next time we go back. Now, the outcome of this was single-digit resource utilization. And ultimately, I guess we didn't really care because it wasn't like it was not our money and it was all internal funny money anyway. But it turns out the cloud kind of flips that script on its head here, or flips the table, I guess. I can scale up, I can scale down, I can do that all on demand. I have limitless compute, although there is a pretty big asterisk at the end of that, additional fees may apply. And if you've ever dug into the fees, you know that they're a little opaque. I love this tweet. After several attempts to stop paying Amazon 80 cents a month, I went in and tried to change everything I could, and I just got a bill for 23 cents. Like, I don't know what's going on. I'm tearing out my hair here. Or this one made me laugh too. I just took a look at the simple cost calculator, and boy, I have a real easy question, like how many dedicated instances of EC2 do I need to spin up the complex calculator? And so I went and looked at it at the time, and this is what it looked like. I think it's changed a little bit since then, but there's a lot of rows for us to fill in. Now, what this has led to, ultimately, is the democratization of infrastructure. That's a win for us because, oh, look, I press a couple buttons and bloop, I have a server. But here's the difference. Our operators knew how to do that, typically, in a more cost-effective manner than we did. We'll just turn stuff on and not necessarily know what we're doing. The reason why the simple cost calculator is not so simple is because there's a lot of things we can leverage. And if we're not careful, we may make some bad decisions there. Do I really need this size? Could I use a smaller size? I don't know if I need this routing thing or this other thing. The other part of this, and this is probably somewhat deliberate, it's very easy to turn something on and then forget about it. A friend of mine told me someone on her team was playing around with a function in a dev environment, and they left it running. At the end of the month, that one function had racked up a $100,000 bill on their cloud spend. Needless to say, that was an uncomfortable conversation with the manager and the VP about, hey, what was going on there? Let's not do that ever again. This one made me laugh too. Hey, we dropped our cloud spend 60% by simply going in and turning off things we weren't using. It's sort of like all those streaming services we've all racked up over the course of the pandemic. We just keep adding them. You don't think about it. It's like, well, it's only $10 a month or $15 a month. And the next thing you know, you're like, wait, how much are we spending? Do we ever use that? Should we get rid of that one? I don't know. We'll think about it next month. In the past, I never had to worry about this. It was someone else's job. My operators were responsible for that. Friends, this is the outcome of the paradox of choice. It's a fantastic book, by the way. If you want to see the short version, you can watch his TEDx talk. I do love his outfit for that talk. I guess that's what happens. It must be nice to be a tenured professor and have a very, very well-regarded book. Democratization demands more of all of us, friends. Or to paraphrase Founding Fathers of the United States, a well-informed developer is a prerequisite to successful cloud deployments. Now, this does lead to another interesting question. What do we want our developers focused on? I was talking with a friend of mine the other day about this, and he was working with a customer, and their approach was fairly complicated. And he told him, he said, listen, with this approach that you guys are trying to go for here, your developers, they really need to be certified in their application framework. You're asking them to be certified in their cloud provider, and you're also asking them to essentially be certified in their container orchestration technology. That's a lot of moving parts for one developer to be responsible for. Maybe that's not the right level of abstraction for them to deal with. So we need to be prepared. We need to be aware of that. And this is an example of be careful what you wish for. I mean, we've been pounding the table for this for my entire career. Why does it take so long for you to spin up a server? I need it now. Okay, cool. Here, we'll give you control. You know what's on the other side of that coin, though? It's accountability. We become accountable for these things. We make a bad decision, rack up a cloud bill, we're the ones who get chewed on for that, not an operator. Let us never forget Uncle Ben's wise words. Or I guess Aunt May, too, depending on which version of the movie you're interested in these days. With great power comes great responsibility. Better have your monitoring story straight in this environment. This is absolutely critical to us doing this right. Some people will call this monitor-driven development. You know, what would you say your service is doing these days? You know, the key components to monitoring for us are logging. What would you say your service is doing? Is your service healthy? Do we have good alerts in place? By the way, be careful with alerting. It's very easy to over-alert. And you know what happens when you over-alert? People ignore the alerts. When was the last time you heard a car alarm and went running to see what was wrong? Mostly it's, oh my God, please shut that car up already. And then tracing. What's going on inside this code base? Now, we could spend an hour just talking about that. We could spend an hour talking about sampling frequency. We could spend time talking about dashboard design, pager duty. This takes time, friends. This doesn't just happen overnight. And again, there's lots of great tools here. And you can get some of this right out of Actuator. It's pretty cool stuff, in my opinion. I may be biased. Friends, automation is absolutely table stakes today. We cannot compete without it. I'm convinced this is why we're seeing so much attention in this SRE space, this site reliability engineering. All right? And if you want to learn more about that, this book is available on the interwebs. You don't have to read it cover to cover. It's basically a series of essays that are sort of thematically grouped together. So what does that mean for DevOps and SREs? I'm very much of the opinion we have to move beyond this idea of DevOps fills out the tickets so the developers don't have to. We need to do more than that. I like SRE better. I think it's a cleaner title. Who doesn't want more reliable applications? You know, do we really want more developer operators? What does that even mean? The moral of the story here is this traditional approach does not give us reliable services because of that tension, because of that conflicting incentives. We want to release early, release often, embrace that always be changing mindset, but that's in direct conflict to the stability that our admins want. Please don't touch it, it works. Again, this is where that trench warfare came from. This is not the way it has to be. It can be better. We actually can get along. We just have to take a different approach. Now, SRE in a nutshell would be, hey, what happens again when you ask a software engineering team to design an operations team? So the goal here is, how do we take some of those principles and apply that to operation? Key here is automation. Give them the opportunity to focus on engineering. A lot of people that get into SRE are themselves former software engineers. Does help to understand a little bit of Unix, a little bit of networking. But again, friends, our operational approach has to change. I've been a part of various things that have review board in the name. They've never worked well. They're extremely heavyweight. I got to fill out a lot of paperwork. And for what? They don't know enough context to say that's a bad idea, Nate, you shouldn't go to production. So they end up rubber stamping everything anyway, and all they did was waste a bunch of time, effort, and energy. How do we move fast safely? That's the goal here. We need an environment that supports all this dynamic, I don't even know how to say that word. That's what happens when I try to throw a word out there. We need dynamic environments. That's the core of what we're driving at here with SRE. How do we create these stable, reliable environments? This doesn't happen in spare cycles. They need to have time to do the engineering work. If they're spending 100% of their time closing tickets, they can't actually automate away the toil. We also need to be very cautious about the technical sprawl that this can unleash in some organizations. You know, if you thought suburban sprawl was bad, the technical sprawl that we see now is worse, much worse. You know, the promise of microservices says, oh, everybody can use whatever tool they want. That's not great, Dan. Everybody's going to have their own favorite everything. Everyone's going to have their own pipeline, their own metrics. All of a sudden, we got an infinite number of ways of doing something. Please tell me where that unicorn is that knows Go and Haskell and Java and Ruby and Python and C++ and everything in between. How many libraries do I need to support all that? Can I stay current on all that? You know, I mean, we all remember the Equifax hack. Amazing how long that bug has stayed in there. We all remember the Log4j issue earlier. Was it earlier this year? Last year? I don't know. Time has no meaning in a pandemic. The challenge for us is it cannot be a free-for-all. There need to be some guardrails in place. They may be very broad guardrails. Some organizations, it's, hey, if it runs on the JVM, knock yourself out. My previous company, here are the 3 flavors that you can use. Pick one. If that won't work for you, then let's have a conversation where I'm going to tell you you're wrong. Pick one. We need to focus on paved roads. This is what even the most developer autonomous companies are doing. Here is a well-worn path. We know it works. We know how to support it. We have countless examples of moving code to production using this approach. If you choose to go on the minimum maintenance road, good luck to you. I hope you brought your snow chains. In other words, you build it, you own it. Sprawl tends to exacerbate our accumulation of technical debt. Again, with great power comes great responsibility. You build it, you run it. Now, is this just DevOps? I mean, maybe. Maybe it's an extension of that. I don't know. We could have a debate, I guess, about SRE being some kind of an implementation detail of DevOps. That'd be a lot more fun to have, you know, in the after party. We've come a long way in this industry. We still have a ways to go. The moral of the story, friends, is we have to be willing to change how we do things. We have to evolve. We have to adapt. I wish you luck. Well, friends, thank you so much for hanging out with me. This has been so much fun to be back out here with you all, so thanks for making this possible. I hope you enjoy the rest of the show and enjoy lunch. Cheers, everybody.